everybody. Sorry that I'm unable to be there today. But, as you know, I've had a baby. Everything looks great, and I can't wait to see y'all. We will talk about your tests on Tuesday and ways that you can improve that score. So, without further delay, I'll let you get through this topic. We're going to talk about polar coordinates. The whole point of polar coordinates is to take functions that are not necessarily difficult, but a lot to write in rectangular coordinates or in x and y coordinates and make them much easier to write in a different coordinate system. So that's why we're going to move from the traditional x and y coordinate system where we have the x-axis as the horizontal and the y-axis as the vertical. And what we're going to do is we're going to take some things from something called the origin or the middle, which we'll have right there is the origin, and which we'll put right there, and then we'll have r, which is going to be the distance from the origin, and theta, which is going to be the distance from where we would have that positive x-axis. And so here is 0. And just like the unit circle, all right, all of our values of theta, or those angle measures, are going to be the same as we had for the unit circle. So here you see that we start at 0, pi over 6, pi over 3, pi over 2, and go all the way back to 0, which would also you could say 2 pi, but we're not going to say 2 pi because 2 pi would be back at 0 because they hold the same position. All right. So that's what the polar system does. And what it allows us to do is it allows us to take, an equation such as a circle. We'll say a circle with center at the origin, which is pretty easy. X squared plus y squared equals r squared. All right. And that would give us an equation of a circle. And in polar, instead of having to write all that out to write the equation of a circle, it could simply be denoted as r equals a certain value. So r equals 3. And that gives us a circle with radius 3, as opposed to if we're doing it in rectangular, it would be x squared plus y squared equals 9. And so both of those equations represent the same thing, but it's much easier to write in terms of polar than it is rectangular. And so that's why we're going to talk about polar coordinates, because when we're trying to graph anything with rounded edges that can be described by a circle, it's much easier to write that or to graph that in polar than it is in rectangular. And so that's why we're going to learn that. So again, instead of using x and y, we're going to use the two variables r and theta, where r is the distance from 0 to the point, and theta is the directed angle counterclockwise from the polar axis to segment OP, which is the origin to the point. So let's go ahead and describe those. So what we're going to do is we're going to look at each of these coordinates. And so here we have coordinate D. And there's actually more than one way to plot or to describe the position of D, and we're going to go through every single one of those. So we're going to do that for A, B, C, and D. I don't know why I said start at D. Let's go ahead and start at A. So here at A, we have the position. The first thing we're going to do is we're going to do R. What is R? It's the distance from the origin. It's much like a radius. That's why we call it R. It's the distance from the center. And so here you see certain, radii you could call, where this would be a circle of radius 1, a circle of radius 2, a circle of radius 3. So how many radii does it take to get to A? Well, it's 1, 2, 3, 4, 5, 6, 7. So that gives us R is equal to 7. So we'll go ahead and put that down, 7. And now that we have R, let's look at theta. What angle measure describes the position of A? Well, I can look right over here, and I see that pi represents that position. So the position for A is going to be 7 pi, because we went a distance of 7 from the origin, and we're located at the angle of pi on our coordinate, or on our polar plane. Now, that's how to do A. Go ahead, if you want to, try and do B, C, and D on your own. So pause the videos. Or you can just keep watching, and I'm going to do it. If you know how to do it, kind of speed through. So let's look at B. B, you have a distance of 1, 2, 3, 4, 5, 6. So we can go ahead and say that R is 6. And then the position for B, notice that it's not already labeled outside here. So if you want to, you can go ahead and label this as 0. We have pi over 6. Then you can put in we don't have any of our pi over 4. So like this would be the position of pi over 4, pi over 3, pi over 2, 2 pi over 3. 3 pi over 4 would be there. 5 pi over 4 would be here. 7 pi over 4 would be there. And so when I look at the angle position for B, it looks like we're moving towards 3 pi over B. And so that's going to be our angle B. 3 pi over 4 for B. Let's look at C. All right, C, we have a distance of 1, 2, 3. All right, so 3 from the origin, and we're headed towards the angle pi over 3. And now to do D, we are 1 away from the origin, so radii is 1, and our angle measure is we're moving closer to 11 pi over 6, so we'll go ahead and say 11 pi over 6. Now, that's how to do it. That's when we want to write out our coordinate, and R is positive and theta is positive. Now, what happens if we want to label these with a negative R and a positive theta? Well, that's not going to be too difficult. What you need to understand is if R is negative, remember, R is the distance that you are from the center. So if you have a negative R, what you're doing is instead of moving towards that angle, you're actually moving away from that angle. All right? So let's go ahead and start at A. All right? Typically, we are moving towards, if we were to do this in both positive, we're moving towards the angle of pi. Well, what is the exact opposite angle that we're moving away from? Well, instead of moving towards pi, we are moving away from 0. So what you can say is our angle measure for this would be 0, and our R value would be we're moving 7 away from 0. Notice that we're going the opposite direction. Because we have chosen to go the opposite direction, we can go ahead and say that it's negative 7, 0. We're going 7 away from angle 0. All right, let's try B now. So again, instead of it being 6, it's going to be negative 6 because, again, it's still at the distance. Now this is a direction. We're moving away from an angle. So when I go over here, I'm moving towards 3 pi over 4, but I'm moving away from, what's the opposite angle of 3 pi over 4? 7 pi over 4. So I can say my angle is going to be 7 pi over 4, but I'm moving away from that angle, so it'd be negative 6. All right, so let's look at C. All right, again, I'm 3 away, so that's going to be negative 3. And what am I moving opposite of? I'm moving opposite of 4 pi over 3. Again, 1, 2, 3, and I'm moving the opposite of that. So that's why R is negative. So when R is negative, you're just moving in the opposite direction. All right, let's go ahead and do D. We know that's going to be negative 1 just by looking at what it was. But now, in order for us to use negative 1, what are we moving away from? Well, we're moving away from this angle, which is 5 pi over 6. So we're going to go ahead and write that down. 5 pi over 6. Beautiful. All right, now what happens? Ring thing is always going off. So we have r negative theta. So now we're still moving towards an angle, but now we're using all of our negative angles. So something that could help you out is to label all of your angles as negative. So remember, going counterclockwise is the positive direction. Going clockwise is the negative direction. So we could say this is 0. This could be negative pi over 6. This would be negative pi over 4. Negative pi over 3. Negative pi over 2. Negative 2 pi over 3. Negative 3 pi over 4. Negative 5 pi over 6. Negative pi. Negative 7 pi over 6. Negative 5 pi over 4. Negative 4 pi over 3. Negative 3 pi over 2. Negative 5 pi over 3. Negative 7 pi over 4. I think I wrote 2 negatives there, so let's go ahead and get rid of that. And let's see. We have negative 11 pi over 6, and then we're back here at 0. You could say negative 2 pi. All right. So now let's go ahead and label these with negative. So when we look at A again, instead of saying r theta, we could say r negative theta. So r, you're moving towards that angle. So that's still going to be 7. But now let's say we're moving towards the negative angle, and that negative angle would be negative pi. So we're going to go ahead and say it's going to be 7 negative pi, because we're moving towards negative pi. All right, r we say is 6, and we're moving towards, looking at B, we're moving towards the negative angle, which is negative 5 pi over 4. So I'm going to say 6 negative 5 pi over 4. Go ahead and do the next one, which is going to be, I know that's going to be positive 3. And which negative angle are we moving towards? We're moving towards negative 5 pi over 3. So negative 5 pi over 3. And then D, we're moving towards 11 pi over 6. But we want to do the negative, so it's going to be negative pi over 6. So we're at 1 negative pi over 6. All right, and then lastly we have negative r and negative theta. So to do negative r and negative theta, we're going to start at A, and we're going to move, now we're going to move away from an angle. Well, what angle are we moving away from? All right. So go this direction, 1, 2, 3, 4, 5, 6, or sorry, 7. All right, and then what are we moving away from? Well, we're moving away from 0. So this one's going to be negative 7, and you're not going to say, negative 0. You just go ahead and say 0. You can also set negative 7, negative 2 pi. Now let's do B. We're moving away in the negative direction again. So again, we already know it's going to be a negative 6, so we want r to be negative. But what negative angle are we moving away from? Well, to get to B, we're moving away from negative pi over 4. So I'm just going to go ahead and change that to negative pi over 4. Again, we're moving away, so we already know we're a distance of 3, so we're negative 3, but what are we moving away from for negative angles? And so again, we're moving 3, and we're moving away from negative 2 pi over 3. And then lastly, we have D, which we know we're moving a distance of 1, so it's a negative 1. And what are we moving away from? Negative 7 pi over 6. And that's how you graph polar coordinates. And again, there's 4 different ways that you can plot these coordinates. You can use a positive r, positive theta, negative r, positive theta, positive r negative theta, and negative r negative theta. And you need to make sure you know how to do each one. All right, that is page 1. I'm going to stop the recording and then do a new one.